Did you know a cockroach can live for a week without its head? It's true. These hardy creatures are infamous for their resilience. They can survive extreme temperatures, high doses of radiation, and even being submerged in water for up to 40 minutes. But what happens if one of these seemingly indestructible critters ends up in a place it shouldn't be, like your stomach? Many people shudder at the mere thought of swallowing a cockroach. It's a scenario straight out of a nightmare, conjuring up images of creepy crawlies invading your insides. But before you reach for the nearest bottle of bleach, let's take a deep breath and explore the truth behind this unsettling event. The human body is a remarkably complex and resilient machine. It has defenses in place to deal with unexpected visitors, even the six-legged kind. Insects often get a bad rap. They're perceived as dirty, disease-carrying pests. While it's true that some insects can transmit diseases, this is far from the whole story. Insects play a vital role in our ecosystem, from pollinating plants to breaking down organic matter. They're also a valuable source of protein in many cultures around the world. Let's debunk some common myths about our six-legged friends. Firstly, not all insects are dirty. In fact, many insects are meticulous groomers, spending a significant portion of their day cleaning themselves. Secondly, not all insects bite or sting. The vast majority of insect species are harmless to humans, and many are even beneficial. Finally, eating insects is not as unusual as you might think. In many cultures, insects are considered a delicacy, enjoyed for their unique flavor and nutritional value. From crunchy crickets to savory grasshoppers, insect cuisine is gaining popularity worldwide as a sustainable and nutritious alternative to traditional protein sources. So the next time you encounter an insect, remember that there's more to these creatures than meets the eye. They're an integral part of our planet's biodiversity, offering both challenges and benefits to human society. Let's imagine a worst-case scenario. You accidentally swallow a cockroach. What happens next? As we discussed earlier, your mouth and stomach acid provide the first line of defense. But let's say the cockroach is particularly hardy and survives this initial onslaught. What happens then? The cockroach would continue its journey through your digestive system, traveling through your small intestine, where nutrients are absorbed, and then into your large intestine, where water is absorbed and waste products are formed. Throughout this journey, your body's immune system would be hard at work. White blood cells would identify the cockroach as a foreign invader and launch an attack, releasing enzymes and antibodies to break down its tissues. The cockroach's exoskeleton, made of chitin, is indigestible to humans, but the rest of its body would be broken down by your digestive enzymes, absorbed, and eventually excreted. In other words, your body would treat the cockroach like any other food source, albeit a rather unappetizing one. While the thought of swallowing a cockroach is undeniably unpleasant, the reality is less dramatic than you might imagine. Your body is well equipped to deal with such unexpected intrusions. Now that we've explored the surprisingly resilient digestive system, let's delve into the world of toxins. Poisons and venoms are often used interchangeably, but there's a crucial difference between the two. Poisons are toxic substances that harm the body when absorbed or ingested. Venoms, on the other hand, are toxins injected into the body through a bite, sting, or other wound. Think of it this way. Poison is like a landmine. It sits passively, waiting for its victim to stumble upon it. Venom, on the other hand, is a guided missile. It's actively delivered into the target. This difference in delivery method has significant implications for how toxins affect the body. For instance, some poisons, like cyanide, are deadly when ingested, but harmless when touched. This is because cyanide needs to be absorbed into the bloodstream to exert its toxic effects. Venoms, on the other hand, are designed to bypass the digestive system and enter the bloodstream directly. This allows them to act quickly and efficiently, delivering their toxic payload directly to the target. Snake venom, for example, contains enzymes that break down tissues, causing pain, swelling, and tissue damage. The venom's potency and effects vary depending on the species of snake, but in all cases, it's designed to incapacitate prey or deter predators. From the resilient cockroach to the intricate workings of poisons and venoms, the natural world is full of surprises. What may seem like a horrifying experience, swallowing a cockroach, becomes less daunting when we understand the body's remarkable defenses. Our digestive system, a complex and efficient machine, is capable of breaking down and neutralizing most unwanted intruders. The distinction between poisons and venoms highlights the intricate ways in which toxins interact with living organisms. The study of poisons and venoms has led to numerous medical breakthroughs, including the development of antidotes and the use of venom components in pain management and other therapies. The world around us is teeming with wonders, both beautiful and bizarre. By exploring the science behind seemingly mundane or even unsettling phenomena, we gain a deeper appreciation for the complexity and resilience of life. So, the next time you encounter a creepy crawly or hear a tale of toxic encounters, remember that there's more to the story than meets the eye. Embrace the curiosity, delve into the science, and marvel at the intricacies of the world around us.